Hello, I'm Farai and this is my code lab. Welcome back to where I go through CTCI. We are now on 1.3. I did 1.1 and 1.2 the last time, but I was a clown and I forgot to record audio, so the video has no sound and it's unlisted. I'll link it in the description if you want to see it. So this one, we're doing 1.3. which asks us to write a method to replace all the spaces in a string with %20, which is the URL encoded space. We assume that the string has sufficient space at the end to hold additional characters, and that you are given the true length of a string. Note, if implementing in Java, use a character array. I'm using JavaScript. Honestly, I think the languages I use will make these sort of questions easier. Like, if it was in Python, rather than like figuring out the split function, I could just, or splice rather, I could just do like -1::, whatever. See what I mean? So let's try this out. Like I said, I would have done it the last time, but I think this will take a while. So as you can see here, we have the string with the spaces, as well as the actual length. So I think, well, let me just do this side by side. So let me just write this down. Mr. space John space Smith, and that is, oops, okay, that was up here. And how many spaces is that? Cancel. One, okay. Mr. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. Oh, there's 4. So 1, 2, 3, 4. Right, and 13. So the assumption was that, is it that the spaces are at the end? Yeah, there's sufficient space at the end. So to make my life easier, I'll assume the input is an array. So there's space at the end, so I don't think these are spaces, these are nulls. So I guess, what approach am I thinking of? Like, obviously, you could just make a new string, and encode it that way, but it looks like it has to be done in place. So how I'll approach this is, like, we have the whole length, and then we have like the true string length. So those are different. So let's just make our function signature. Function URLify. This is the URL. And then true end. The true end is equal to shoot, I forgot. True len. Okay, so true end is equal to true len minus 1 because of 0 indexing. Then what I'm thinking of is, you look at the characters, right? And if it's a space, you just switch them. Otherwise, if it's a space, you just switch the character. Otherwise, if it's not, you just put in the 0, the 2, the percent, and then you decrement even further. So let's I wonder what you do like at the end then. Let's figure it out as we go. So guess, well, true end isn't 0. Yeah. Str end is equal to URL dot length minus 1. So while true end is not equal to 0, what we're going to do is, if URL true end, no, not true end, yes, true end is, I'm just doing not equal to make my life easier here. Does the order actually matter in these sort of things? Doubt it. Equal to, we're just putting space here, right? If it's not a space, then URL str end is equal to URL true end, else yeah. So we do URL str end is equal to 0. Then what we get, so we can just do this, and we duplicate and down, and minus 1 is equal to the 2. And let's just copy this again, duplicate, and subtract 2 is equal to percent. And then as we go down 1, go down 2. So we decrement str end by 2, str end minus equal to. Then at the end of this, since we're always gonna go down, what we do is true end minus str end minus. Where we just decrement, and then we could just return the URL. So return the URL. All right. So to test it out, let's just do something simple like AB, like A space B that will just be space, space, right? So, and then the true length is 3, right? So that means we'll have one space. So the str len is equal to the length 4, right? Then true len is equal, because this is 5 minus 1, so true length is it's the 3 minus 1. So that means it starts there. So so let's see which is true. So 4 2 st. So is 4th equal to the 2nd? And the answer to that is no. Is it equal to space? And the answer is no. So we'll end up having a space, space, not space, it doesn't matter. A space b space b, right? So then we decrement both of them by 1, so we have 3 and 1. So now is this space equal, is this a space? Yes. So we'll do our A. Okay, so this is our B. Then you swap it out for a 0, you go down once, you swap it out for a 2, you go down once again, swap it out for a %, and then the str end, we decremented it by 2, right, already. So then we decrement it by, which gives us 1, and then we just get 0, 0. And yeah, that's about right. But I wonder, does it have to be equal to 0, or can they all just, like, if they're all equal, like if they're at the same point, then I doubt there's any spaces left to look at. So it's not equal to str end. So let's use our Mr. John Smith. So whoa. Okay, this is our example, the Mr. John Smith. So I was trying to see some. Oh yeah, because there's like, I'm trying to see, there's like no point in continuing if the pointers are at the same place, since you can assume there's no more space to like push out. But let's try this canonical example here. So S and the true, so the S is actually it's here, so it's not the 13, it's 12, and then shoot, it's at the 12, and then the S is the one, okay, 13, 14, 15, 16, 17, so 16, right? So the first one round is H, you don't know, so it's just MR space JOHN space S M I T H space H. Just decrement 15, 11. Then the same thing. So is T equals to null? No, so T space H T I M S space and H J space R M. Do I really need to write it out like this? So we decrement again. H T I space H T I M S space N H O J space M 13 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 12. Oh no, 1, 2, 3, 4, 6, 7, 8, 9. Yeah. So H T I. Oh no, 1, 2. Oh no, that's right. M H T I M S space N H O J space R M minus 1, 12, 8 H T I M S T I M S space N H O J space M. Alright, now for some fun. 7, because we now have our space. So H T I M S. So we have, oh yeah, so since we're at a space, you get a 0, you get the 2, and you get the percent, right? Then we have the S space N H O J space R M. So then the T. Oh, no, 6. And this one's 3. 1, 2, 3. So it's 9. So, shoot. 1, 2, 3, 4, 5, 6. The M is the 6. So, oh my god. 6. Oh no, it's not. It's 8, not 9. 8. H T I M S 0 2% 0 1 2 3 4 5 6 7. Yes, 7. So 8. Oh yeah, so we don't need that S and that dot. So we just have N space N H J space R M. Decrement 7 and 5. H T I M S 0 2% N blank and not blank and swap again. You get the O and oh, the H J space R M, and then 6 4 H T I M S 0 2% N H O H O J space R M. 5 and 3. HTIMS 2% and H. Oh, okay, 5, 0, 1, 2, 3, 4, 5. J, O, J, R, M, then 4, 2. All right, this is another interesting spot. Okay, because there's a space here at 2. So we do the 0, the 2, the percent. And we go R and M. Oh, shit. Yeah, I think I'll just, RM. Because it was 2. No, it's 4. And it's 2. And then, oh, yeah. It's just 1, 1. And that is what's returned. And yeah, that's it. This took a lot faster than I thought it would. And I might have missed something. So 53 was the tip. I couldn't be bothered to look at it in here on the iPad. So tip number 53. It's often easier to modify strings going from the end, which is what we did. And 118, which says that might need to know the number of spaces. Can you just count them? My solution relied on none such. So let's look at the answer. Shall we? Alright, solution. A common approach is to add the string starting from the end and working backwards. This is useful because of the buffer, which allows us to change without overwriting. Yeah, we did that. We used this approach. So this is what happens. So it counts spaces. Okay, so we'll use this algorithm. It's a 2 scan. The first scan, we count the number of spaces. By tripling this, we can compute how many extra characters we'll have in the string. The second pass, which is reverse order, we edit the string. When we see a space, we replace it. Okay. Implemented in character arrays. If we will need a copy, well, I did it in one pass. You saw that, right? So I'm trying to understand. So they're counting the spaces, right? Space else. This is just the same thing I did. In fact, I saved a loop. I don't know why I need to do the whole string counting thing, so. Now, 1.4, Palindrome Permutation. Alright. 1.4 is a palindrome permutation. Right, so let's jump back. Okie dokes. 1.4 Palindrome permutation. Given a string, write a function to check if it's a permutation of a palindrome. A palindrome is a word or phrase that is the same back or forwards. The palindrome doesn't need to be limited to dictionary words. Check if it's a permutation of a palindrome. That is literally just the permutation check. No, but what's a palindrome? So, okay, what do you know about a palindrome? Okay, a palindrome. What do you know about it? It's the same backwards and forwards. All right. Okay, so it's the same backwards and forwards. And what needs to be true in order for that to be so? It's the same back and forward. That means they have an even count. Every character is even. Like every character is even. So noon, for instance, has 2 N's and 2 O's. And then car or only one even, only one odd, right? So in this case, it's 2 times R, 2 times A, 2 times C, 1 times E. So we know that either every character is even or there's only one odd. So this isn't as hard as it sounds. Function is str, standard technique of frequency table. Is a frequency table. So CHRS zip for I equals 0, I less than str dot length I plus if CHRS STRI, then CHRS I don't think there's a plus equal with these, right? Since it's not exactly a variable. So yeah, so I don't know why I get tired when I need to do the things I need to do, you know? Plus. There's no difference, really. Else. Duplicate. And else that's equal to 0. Right? This literally looks like this is like 1 and 2. Literally. So that's that. All that for freak of CHRS dot values odds. One, because it's either all evens or one odd. So if freak mod 2 is equal to 1, then odds minus minus, and if odds is equal to 0, then the way I'm mixing like Python and then return false. Otherwise, yeah, it only matters if it's odd. Then we just return true. So let's get our taco cat. So tact space koa. So we built the frequency table. T2, A2, C2, space 1. So this fulfills it, and yeah, let's go lark B1, 1, A1, R1, K1. Does blark mean anything? Let's ask Siri. Never mind, Siri. Never mind. So, they're all odd. So you just go the 1, 0, and then it just goes. I think you could use the I, the minus, I, minus thing. I don't know the difference. I think one of them is supposed to return itself afterwards and before you manipulate the value, but I think I'm right. Let's just see the tips. See the tips. Just in case. So, 106. The tip is you don't have to generate all the permutations. That would be inefficient. Do I even know how to generate permutations? I was thinking of like that one formula with the, oh my gosh. You know, it reminds me in college once. Like, this is why I say I love Python. It's like, it just, they call it batteries included. It just does everything, well, a lot of things which you just don't need to think about, unlike JavaScript where you have to leap through to an npm module just to check if a value is true or to pad a string. Those were good times. Anyway, so I needed to generate permutations for an exercise. I forgot exactly what. And they were going through the algorithm for generating permutations in case we needed it for an exercise. And I was like, yo, can I just use this Python collections module? And he's like, whatever. So why waste time like writing out the algorithm for generating permutations when in Python there's literally, like, you could literally import it. It's in the collections module somewhere. So, oh my goodness, sorry for that rant. 121. What characteristics with a string? As we've said, we've established those. They're all evens or there's one odd. 134. Have we tried? Yes. And 100. Oh, it asks about a hash table. Can I reduce the space with the bit factor? I can. I just don't know how to. So, yeah, let's look at the answer for that now. And it just feels so weird talking to myself. Like my own consultant. As that Lil Wayne song goes. 6 foot, 7 foot. Have thoughts on Lil Wayne, but that's out of the scope of this video and ventures into politics. So anyway, here we are. So this is a question where it helps to figure out what it means. Yeah, which we said, it's the same forwards and backwards. Therefore, decide if a string need to know it's written such, then what does it take? You need to have an even number of almost all characters. That half can be on one side and the other half can be another, and one character can have an odd count. Because, yeah, to be even more precise, strings with even length must have all even counts. String with an odd length must have exactly one character with an odd count. Of course, an even string, okay. Yeah, so that leads to the algorithm, so found false. Yeah. Generate. Who gives a shoot? I'm gonna keep it friendly. Can't optimize big O since we have to look through. However, we can make, because it's simple, it's making small. Where did it go? Small optimizations, yeah. So instead of checking the odd counts at the end, you just check as you go. That's smart. So it's not necessarily more optimal. It has the same big O, and it's a bit slower. We just got rid of an iteration, but now we have to run some more code. So it's not necessarily that much better, is it? Because like you're just doing way more memory access and all that. You know, it's one interesting thing with like the overemphasis on like the big O's and stuff. Like, yeah, it's big O's worst case, right? But it's assuming a lot. Like, for instance, let's take space storage, right? Like, the space in your RAM, this RAM is different from, like, the cache. And then even in that cache, there's, like, L1, L2, L3, which those are all different, so all the memory isn't really the same. So you might say like, oh look, it's space sufficient, but if the space is like just keeping banging on the the virtual memory, then like the other one, which is less space efficient but just keeps hitting L once, is it really much better? What do you think? Anyway, I'm so sorry. Like I said, the last answer is like a bit. I think it's just a bit manipulation. So. Okay, so we've done 2. How long have I been at it? 40 minutes. I think I'll end here. I remember having a lot of trouble with one away once. So, yeah, thanks for watching. I apologize for the rant. No, actually, I don't apologize for those rants. I'm just telling you what I think. I mean, in an interview, he'll just be asking me questions like, what do you think about this? Where could you improve? Then, like, we just go back and forth, da 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 da. I mean, if you don't find these helpful, but I'm just trying to go through this book. My friend bought it as a birthday elephant gift. No, not white elephant. See, not even Secret Santa, since we asked each other what we want. Yeah, we just exchanged gifts. Like, he wanted a calculator. He's an actuary now. I don't know what he's up to now. I can't just message him out of the blue, say, hey, Mike, what's up? Oh, no, I doxed him. You don't know his surname, but I can't just be like, hey, Mike, what's up? How's the actuary stuff going? So, I'll just leave it out. So, yeah, thanks for watching this. Next time, we can do one away and string compression, and next Monday, I think we'll finish the chapter. So, yeah, thanks again for watching. You've been good, and I'll see you next time.